This log data to workspace is really very helpful when you are dealing with simulations. For example, you want to study this thing in future, you want to analyze different outputs, you want to store this data to use in future or to use somewhere else. There could be many reasons to store the data in workspace. So now we are going to explore that how we can store the data in scope to workspace variable with minor details and small comparisons. So now let's get started. Okay, so this is our circuit. This circuit we have prepared in our previous video. In our previous video, we have learned about scope. In that video, we have gone through all the tools in the scope, including this file menu, tool menu, view, simulation, help, as well as measurement, styling, zooming, and many more about the scope. If you want to watch that video, I'll provide the link in description box below and above here in card. But in this video, we are interested in something else. This is the data in scope, and we want to store this data into the workspace in our defined variable. And for that, we'll go to the configuration properties and logging. In logging, there is a tool called log data to workspace. You need to enable it. Once you enable it, the first thing you will find is variable name. Over here, you can give any variable name. I have already given the name of the variable one signal, and then save format. There are 4 different formats available in which you can store this data. We'll go through each of the format one by one. First, we'll start with the array. So we'll save this data as array. Once you click OK, you need to run the simulation again, and then we'll jump to the workspace. So now here in workspace, you can find one signal variable. The size of the variable is, it has almost 1 lakh rows and 2 columns. So let's explore that variable. So these are the 2 columns. So we have 1 lakh and 2 rows and then 2 columns. So first what we'll do, if you want to access these variables, how you can access this variable? There are 2 ways to access the variable. One is just directly by writing the code, and the second is using this plot. So I'll show you first the simple method and then by code. So here column number 1 and column number 2. If we observe these 2 columns, right, we can see that the first column, the magnitude of first column is gradually increasing and the second column is varying. So observing these readings, we can know that the first column is time and the second column is amplitude. So we'll select entire column number 1. When you select entire column number 1, you can see that varieties of graphs are highlighted. So from here you select any one graph, right? So we'll plot this. Once you select it, you can see that on y-axis there is time and on x-axis there is numbers of readings that we have taken through the simulation. Now we'll close it. We'll do same thing for the next column. We'll select entire column, select plot, and now you can see we have the graph of amplitude. On y-axis it is amplitude, and on x-axis we have the numbers of total readings or numbers of total points that we have taken through simulation. So it is very simple to plot individual quantity, time and amplitude. But now I'll show you how you can do that thing using the commands. We'll close this thing. So if you want to access these variables manually and if you want to plot the graph manually, what you can do, you just need to write plot, then write the name of the signal. The name of the signal is provided over here, one signal. So you need to write one signal. Then in one signal, to plot the graph, we want to include all the rows. So we'll use this gem to select all the rows, comma. Now we want to go for which column we want to plot. So we'll select either column number 1 or you can select column number 2. If you want to plot amplitude which is given in column number 2, then you need to select column number 2, bracket over, second bracket over, and enter. And there we go. Here we have the graph. Now close it. Using this direct plot, you can plot individual columns, right? But what if you want to plot the graph where x-axis is time and y-axis is amplitude? For that, we'll make it a little bit bigger. We'll use the same command plot, but here to plot x-axis, we'll use column 1 because this column is of time. So in plot x, we'll use all the rows and column 1, then comma, one signal, that is the name of the variable, all the rows and column number 2, this one, and then we'll run. So this is how you will get time on horizontal axis and amplitude on vertical axis. So this is how you can deal with array format. So let's go to configuration property, logging, and now we'll check other data formats. So first data format that we have checked is array. Now let me tell you that where to use array. When you are using only one set of axes, at that time you should go for array. But when you have more than one set of axes, at that time you need to go for either structure or structure with time or dataset. Now let us explore that thing. Here we have another scope. Here we have multiple set of axes. So in this case, we'll go to logging, enable this log data to workspace. The name of the variable is 3 signals. So first we'll go for structure, right? Now before going to structure, what if I select array when I have multiple set of axes? Apply, OK, and when I run the simulation, it shows an error. Simulation does not support array format for logging multiple data, right? So here we have multiple data set of axes, so we should not go for array. Now we'll go for another type of data set, and that is structure. Now we'll run it again. So here it is, our workspace. This was our previous variable, 1 signal, and here it is the new generated variable, 3 signals. You can see here the 3 signal is 1 cross 1 structure, right? So when we double click it, it will pop up a window where you can see time, signals, block name. If you open time, the matrix is completely empty. 3 signals dot time matrix is completely empty. The second field is signals. It is basically a 1 cross 3 structure. When you open it, you can see that 1 column and 3 rows. This shows the dimension, label, title of the signals, and plot style. So here the data of each of the individual graph is stored in this variable 3 signals dot signals. So here in 3 signals dot signal variable, we have the data of multiple set of axes. Here you can see that we have 3 axes: sine wave 1, and addition. When we open this signal, the first one is sine wave, second is sine wave 1, and the third one is signals. So here when you open any of this variable, then you will find amplitude measured in various points that have been stored in this matrix. So ultimately all these things are the amplitudes. Let me plot the graph of this. We'll select this, go to plot, and select the plot. So you can see that over here we have the plot of amplitude. On y-axis it is amplitude, and on horizontal axis the total numbers of reading that we have taken in scope. But one thing is missing over here is there is no time data, right? The time data is not available in this structure format. We'll close this thing, we'll open another one, same thing here. you will not be able to see any time data. When you plot it again, you will be able to see the graph of amplitude versus numbers of points. But time is not stored in this variable. We'll close it. So in structure format, you can store the data of more than one set of axes, but without time. Now we'll close this thing and we'll go for the next type of format, that is structure with time. So in this format, you will save all the data that will be able to save in structure, but the additional data will be time. So whenever you want to store time with your other data, you should go for structure with time. Make it okay and run the simulation. Go to workspace. So here in workspace, we have three signals, 1 cross 1 structure. We'll open it. The first is time, but see here you will be able to see the difference. Initially the value was 0, but right now we have a matrix of 1 lakh cross 1 double, right? So we'll open it and we'll be able to see the different values of time. There are total 1 lakh and 2 values from 0 second to 10 second. The next variable you can see is signals. So in signals, we have again the same 1 cross 3 structures. When we open it, we'll find the same thing as we have seen previously in structures, right? All the things is same. When we open any of these things, we'll be able to get all the amplitudes of the signal. So basically, what is the difference in between structure and structure with time? It is very simple. In structure, you will have the data of amplitudes of all the signal. But when you store the same thing in structure with time format, you will be have all the data of amplitude as well as time. So here we have additional advantage that we have value of time. Now, if you want to plot the signal, the method is same. You just select any of the column, go to plot, select, and here we have the plot, right? If you want to plot the time, we'll go to time, select the signal, plot, and here we have the time. Now the same question arises again, but here the same question arises, what if I want to plot time versus amplitude? So for that, it is very simple. You need to write variable's name. Here time is stored in 3 signals dot time. It is the name of the variable where the data of time is stored, and 3 signals dot signal 3 dot values has all the values of amplitude. So we'll plot the signal. And here we have the graph of time versus amplitude. So you can access any of the variable in structure with time, or in array. The thing is, you need to use the appropriate name for that particular variable. That's it. If you use appropriate name, you can use the data. To simplify it, you can store this variable into a simpler name like y is equal to and enter. So here we have a y variable. When you double click a y, you will have this 1 lakh 2 cross 1 data set. Clear the screen. So this is how you can deal with structure and structure with time. Now we'll move ahead. The next is data set. But before we proceed to dataset, there is a quick short question for you. Your question is, what is the advantage of structure with time data format? You need to write the answer in comments below, and if you have any doubt, you can contact me by asking your question in comments, or you can directly live chat with me on my Instagram ID or on my Telegram page. So the choice is yours. You can join me on Telegram or on Instagram or on FB. So now we'll move ahead with dataset. So here we are storing all these things in a dataset format. Okay, let's run it again. Now we'll go to the workspace. So here it is, our workspace. One signal is our first simulation, y we have just created recently, and here the three signals is our variable. You can see here the name of the variable is 1x1 dataset, right? So the name of variable has changed from 1x1 structure to 1x1 dataset. Let's open it. So here you will be able to see each of the signal is stored individually. 1x1 signal, 1x1 signal and 1x1 signal. If we open any of the signal, then in that signal we have multiple data like port, input, port index 1, propagated name, block path, values and name. So our data is stored in these values. The format of these values is 1x1 double time series. So let's open it, and you can see our data is stored with time and amplitude. So the advantage of using this data set is multiple information is stored directly with that variable. Over here you can see that there are multiple information is directly stored with this 1x1 signal, right? If you open another signal, then the same thing you will be able to see. Port index is 3. So here you will be able to identify that from which scope you have taken the data, from which port this data has been taken, the path, name, values. Multiple data is stored in this 1x1 signal. So it is enriched form of storing data. When you open the values, again you will be able to see time as well as amplitude, both these things stored at one place. Now if you want to access this data and if you want to plot the graph, then it is very much easy than the previous method. We'll close this thing and we'll go to any individual variable. So here our variable is 3 signals 3. We'll select the values. When we select it, it will be enabled, and just select the plot. When you select the plot, your data versus time will be directly plotted. Previously we have seen that only the data, that means only the amplitude is plotted with respect to points, or only the time is plotted with respect to points. But if you want to plot time with amplitude, then you have to do some adjustments, right? But here all the data is stored in one variable, right? Time as well as amplitude. So it is not required to do any line of coding. You just select variable and plot it. Close it, close it. So dataset is a little bit advanced version of storing the data in variable. Now we'll clear all these things. We'll go back to simulation. So this is our simulation. Now I'll show you other way to store data to workspace, right? You just need to double click over here and write to workspace. So here we have the block, to workspace block, right? So we'll select this to workspace block with any one signal. When we open it, it will ask us to set the name of the variable. We'll name it as sine wave. The next is limit data point to last. We want to see the full simulation, so here we'll keep infinite only. We'll keep this decimal 1 as it is, but here we have save format. So you will be able to see all these 4 format that you will be able to see in the scope: structure with time, structure, array and time series. So basically this time series is the same as data format or data set format in the scope. Let's say we are selecting time series as well. Apply, OK, and let's run this thing. Now let's go to workspace. So in workspace, one signal is our first simulations variable from scope number 1. This 3 signal is from our scope number 2, where we have connected 3 ports, and this sine wave is from that block, to workspace block. The name of that block is to workspace. So we'll open it. We have stored the data in time series format. And in that 3 input scope, we have stored all these 3 data in dataset format. So let's open that too. When we open that, we have this multiple set of data, but when we goes to the value, right, we'll be having time as well as amplitude. So here we'll directly have that time as well as amplitude when you use the to workspace block. So you will be able to do all these things which you will be able to do using scope. So using this to workspace block, you will be able to send the data to workspace, which you will be able to do using the scope. All these things you will be able to do using to workspace block. Then the question is, if we can do everything with scope, then why this block is required? The simple answer is, there are various signals which you do not need to observe, and the signals which you do not need to observe, you do not connect scope with it. So when you do not connect a scope, then how can you send the data to workspace? So wherever we are not using scope, and if we want to send the data to workspace, we should go for to workspace block. Because if our simulation is very big, very large simulation, and if we are using multiple scopes, then the simulation will take longer time to run. So instead of using more scope, if you do not want to see all the signals, but you want to have all the signals in your variable in your workspace, so it's better to go for to workspace block rather than going for the scope. So that's it from this video. If you enjoyed this video till now, hit the like button, hit the subscribe button if you have not subscribed the channel yet. In next video, we are going to learn how to edit this figure and make this figure a paper ready figure or a report ready figure. So until we meet again in our next video, till the time, bye bye.